Hey, welcome to our explainer. Today, we are going to decode the math that pretty much runs our entire financial world. We're going to follow the money, starting with what's in your wallet and ending up on the trading floors of Wall Street. And you're about to see how they're connected by just a few surprisingly simple ideas.
So let's just kick things off with the one question that frames this whole thing. What on earth could your car loan and some high-tech Wall Street trading algorithm possibly have in common? I mean, one feels pretty personal and straightforward. The other sounds impossibly complicated, right? Well, it turns out the answer is all about a few key building blocks.
Okay, look at this. On the left, you've got a formula you probably remember, maybe even dread it from school. Interest equals principal times rate times time. Simple, right? But on the right, well, that's from a financial math exam at MIT. It looks like it's from another planet. But trust me, by the end of this, you're going to see how that first simple formula is literally the foundation for the second one.
To get there, we've got to start with probably the most powerful force in finance: interest. You know, the best way to think about it is like a snowball. It starts out small at the top of a hill, but as it starts rolling, it picks up more and more snow, getting bigger and faster. That's exactly how your money can grow. First, let's talk about the most basic kind: simple interest. This is just the fee that's calculated only on the original amount you borrowed or invested. That's the principal. It's super predictable. Basically, your snowball just gets a new, same-sized layer of snow added to it every year. That's it.
But this is where things get really interesting. Compound interest. Here, the interest isn't just calculated on the principal. It's calculated on the principal plus all the interest you've already piled up. Your interest literally starts earning its own interest. So now, the snowball isn't just getting bigger, the amount of new snow it picks up gets larger with every single turn.
Let's make this real. Imagine a 10,000 Naira loan. Now that's the currency in Nigeria, but don't worry, the math works exactly the same no matter where you are. So, at 8% interest, in that first year, the math is simple. 8% of 10,000 is 800. Easy enough. Your new total is the principal plus that interest.
But for year 2, look what happens. We don't start at 10,000 anymore. We start at 10,800. So that 8% interest is now calculated on that new, bigger amount. That gives us $864 in interest, which is more than the year before. See, the snowball is starting to accelerate.
Now, check out this side-by-side comparison. The simple interest loan on the left just chugs along, growing by the exact same amount every single year. It's a straight line. But the compound interest loan on the right? Whoa, the growth gets bigger every year. That gap between the two just keeps getting wider and wider. That is the power of compounding.
But of course, it's not always about growth, right? There's this other force that's always pushing in the opposite direction. It's the snowball melting in the sun. It's called depreciation.
Simply put, depreciation is just the loss in an asset's value over time. You know, think about the second you drive a brand new car off the lot, or even just unbox a new phone. Bam! Its value has already started to drop.
Let's take an example from one of our sources: a Palm-top computer that, back in the day, cost 20,000 Naira. That's our starting point, the peak value. And the loss here isn't a slow, steady trickle. Not at all. After just 1 year, its value falls by 12.5%. The next year, it drops by another 20%. By the time you hit year 3, it's lost almost half of its original price. Just like compounding growth, this decay can accelerate too. And this is what's so cool about the math behind it all. On the left, you've got the formula for compound growth. On the right, the formula for decay. Now look really close. They're almost identical. The only difference is one tiny symbol: a plus sign for growth, a minus sign for decay. That single character determines whether you're building a snowball or watching it melt.
So we've got these two really powerful opposing forces: compounding growth and depreciating decay. So what do? Well, the key to building a solid financial future is knowing how to manage them. Let's look at 2 big strategies for that.
First, to really get that compounding snowball rolling for you, you can use something called an annuity. I know, it sounds like a complicated financial term, but really, it's just a fancy name for a simple plan. You put in the same amount of money on a regular schedule. By doing that, you're constantly feeding your snowball, helping it grow bigger and faster.
And on the flip side, to fight back against decay and the compounding interest on a loan, there's amortization. Again, sounds complex, but it's just the game plan for paying off a debt with regular, structured payments. Every single payment chips away at both the original loan and the interest, systematically melting that debt snowball until it's totally gone.
All right, we've got our pieces: principal, rate, time, growth, and decay. So let's bring this all home and connect it back to that first question. How does any of this get us from our everyday money to the craziness of Wall Street?
This quote, taken right from an MIT finance exam, kind of pulls back the curtain. You see, they're dealing with the exact same concepts we are, just on a massive scale and with one extra crucial layer: probability. They're constantly trying to calculate the odds of growth versus the odds of decay for thousands of different things all at once.
And they don't track these things one by one. Professionals use these advanced mathematical tools to bundle everything together. Your car loan, my mortgage, a company stock, all of it. It's a way to track thousands of different snowballs, some growing, some melting, all at the same time in one single elegant equation.
Now remember amortization, that plan for paying off a loan? This right here is the full-blown formula they use to calculate it. Yeah, I know. It looks intimidating, doesn't it? It has brackets, exponents. It looks a lot like that crazy math we saw at the very beginning.
But wait, take a breath and look closer. What do you see hiding in plain sight? Yup, there's P for principal, there's R for rate, and there's N for the number of time periods. It's all there. It's the same stuff. That big, scary formula is just built out of the simple little blocks you now understand.
And that's really the secret, isn't it? From the interest on your savings account, all the way up to a multi-billion-dollar investment portfolio, the underlying language of growth and decay is exactly the same. You now have the key to decode it. So the only question left is, how are you going to use this language to write your own financial story?